Hello everybody and welcome to the very first video of the semester for our course. So in a nutshell, multivariable calculus is about calculus in 3 dimensions. If you've read any of the preliminary course material, you might have already stumbled upon these words. And so in this first chapter, in these first few sections, we're going to be talking about how do we describe points, positions, and functions in 3-dimensional space. That's going to kind of form the groundwork of what we do this semester. All right, so we're going to work through a couple of examples on page 5 of our workbook here. Okay, let's take a look at example 1 together. So they'd like us to plot a few points in 3-dimensional space. Okay, and this is going to be a new concept for a lot of you. So let's look at the diagram that we see over here to the right. Notice that there are 3 axes, an x-axis, a y-axis, and a z-axis. Okay, now this is a 2-dimensional picture, but it's really representing a 3-dimensional situation. Okay, so if you want to help yourself picture this, what you could do is maybe go to a corner of your house where 2 walls meet the floor. Okay, so over here we've got wall 1, wall 2, and down here is the floor. And here's the corner of the room. That's going to be the origin of our coordinate system. Okay, that's where x, y, and z are all 0. And the thing about this is we can use this coordinate system to describe any point we want to in the room in 3-dimensional space. Okay, now this problem specifically wants us to locate a couple of points. Let's start with P, 0, 0, 2. Where would that be? Okay, well, remember that these are coordinates x, y, and z, so it's telling us we want to move 0 units in the x and the y direction and then 2 units in the z direction. So we'd start here at the origin and we'd simply go up 2, and that would be where P is. Okay, notice that point is exactly 2 units up from the origin, above the floor. Okay, and moving on to Q, where would that point be? 3, 4, 0. Okay, well this time we want to move 3 units out on the x-axis, so 1, 2, 3, and then 4 units on the y-axis. That's going to put us here, and then we're not going to move up at all on the z-axis, so there's where Q is. Okay, 3, 4, 0, that's sitting on the floor, but it's away from this corner of the room at the origin. Okay, what about R and S? Well, starting with R is 0, 4, 5, so we want to move, we'll start back here at the origin. Whoops, excuse me. And we want to first move 0 in the x direction, 4 over in the y. That's going to put us here. And then we want to go 5 units up. Okay, if you count the ticks on the z-axis up to 5, that's going to put us here. Okay, so there's the point R. Okay, it's kind of sitting in wall number 2, but 5 units above the floor. Okay, and then finally, what about S? 3, 4, 5. This time we want to move a little bit in the x, y, and the z direction. So we're going to go 3 units in the x, then 4 units on the y, which is going to put us at Q, and then we want to go straight up 5. Okay, and so S is going to be sitting there. Okay, and the idea of this coordinate system is you can describe any point you want to in the room or in 3-dimensional space, however you want to think about it. Okay, so that's example 1, and example 2 introduces us to the idea of functions in 3-dimensional space. All right, so let's look at a couple of typical examples. They're giving us a function f of xy equals x squared plus y squared, and g of xy equals 3. The thing to notice about these functions is that they have 2 input variables, x and y. And for the output variable, generally, we give outputs the name z, so there are actually 3 variables involved in these functions, x, y, and z. Okay, now let's see what they want us to do with these functions. So first, they'd like us to evaluate f at several values of x and y. They just want us to pick some input values and see what we get for output. So let's do that, and we'll pick some reasonably nice numbers. How about 0 and 0? What would f of 0, 0 be? Well, we're just going to take 0 for x and y, substitute both of those into our formula. We're going to get 0 squared plus 0 squared is 0. And so 0 is our output. That's our z value. What about f of 1, 0? Well, same idea. This time we substitute those into our formula. We're going to get 1 squared plus 0 squared. That's 1 for our output. Let's do one more. What about f of 2, 3? What would we get there? Okay, well, 2 squared plus 3 squared, that's 4 plus 9 is 13 for our output. Okay, and we could generate all the points that we want. Okay, and that's kind of all they wanted us to do with f. What would they like us to do with g? Well, they'd like us to sketch a graph of g. Okay, and this is the first time that we've graphed a function where 3 variables are involved. Okay, so let's do this slowly together here. I'm going to start by drawing our axes, x, y, and z. Okay, and this is the same picture that you saw above. Okay, and let's think globally about this function g. Okay, it's telling us that no matter what x and y value we plug in, we're going to get 3 as an output. Okay, so how would all of the points in three-dimensional space look if the z-coordinate is always 3? Well, it's like saying we're talking about all points that are exactly 3 above the floor. Every single point, no matter what x and y are. So if you think about it, that's really describing a flat surface, okay, that has a height of 3. Okay, and you're going to quickly discover that my drawing skills are not the greatest, so bear with me here. Okay, so this point is 3. And so the equation, g of xy equals 3, is just a plane. Okay, it's a flat surface. Every z-coordinate has a value of 3 on it. Okay, and we've completed this example. I just want to make one last comment about the function f. They didn't ask us to graph this function, but if you want to see a picture of it, you could sneak a peek at page 7, the top of page 7. There's actually a graph of this function f of xy, and you can maybe take a look.